Hello, welcome to ICSE 2021. My name is Rafał Włodarski and I'm here overlooking a beautiful cityscape of Madrid to present you a controlled experiment entitled Assessment of a Hybrid Software Development Process for Student Projects. I'll start with a quick introduction, then present the assessment method and the context of the study. Afterwards, I'll discuss the results we obtained and conclude with a brief summary and guidelines for the teaching community. As the software industry evolves, so do the development approaches used. In recent years, practitioners started devising hybrid methods to improve on certain aspects such as productivity and product quality. Academia strives to follow industry practice, however, there is a shortfall of documented cases where hybrid ways of working guided student undertakings. With this study, we aim to bridge that gap by answering the following research question. Does a hybrid method yield better results for student projects than the processes it combines? To answer the research question, we aim to capture multiple facets of project success and investigated the following areas. Product quality in terms of internal and external characteristics of the produced artifacts. We took a look at the source code metrics such as HTML code quality and maintainability index. The latter consolidates multiple aspects of code such as its complexity, size, and dependency counts. To assess the external quality, we focused on the number and severity of bugs detected in the final software. The second success dimension was team productivity, which was expressed by the ratio of functionalities delivered and specified in the assignment. We also investigated human factors of students' work, which encompassed teamwork quality, examined by one of its facets, team cohesion, as well as acquisition of 5 technical and 5 soft skills. The latter were related to pillars of efficient collaboration, such as teamwork, collective decision-making, and planning. We took these extensive measures at a French engineering school among 67 students of a telecommunications program. The experiment was carried out within a web programming course where teams of 3 implemented an app to keep track of expenses among friends. As per definition coined by Corman, a hybrid method is any combination of agile and traditional approaches that an organization customizes to its own context. Therefore, to evaluate the effectiveness of a hybrid way of working, we compare it against the process it combines, iterative and sequential. The course population was divided into 3 separate laboratory groups where different processes were introduced. Now, let me briefly describe the structure of the 3 methods applied. Requirements engineering was carried out by the course instructors and a prioritized backlog was provided to students. All teams shared the same assignment, deliverables, and grading scheme. In the iterative approach, there were no formal project phases, as instead, different software development activities were performed repeatedly in cycles. On top of coding and testing, they encompassed a planning exercise for the iteration ahead, weekly progress monitoring by means of team velocity, and a project demo. 5 iterations of 2 weeks were carried out, whose outcome was the final delivery and its documentation. Sequential approach imposed succession through design, implementation, and testing phases, each stage requiring specific artifacts to be produced. As part of the design, students were to conceive their solution and formalize it by means of documentation. Implementation kicked off with a planning exercise for the whole phase ahead, and onwards consisted mostly of coding activities with regular progress checkpoints. They were formally monitored with earned value KPIs. A final phase of testing involved executing prepared test cases, bug fixing, and polishing the application. The hybrid approach used the waterfall model as its underlying phases as the baseline. However, implementation was done in an iterative manner. Similarly to the sequential approach, the development process progressed through dedicated design, implementation, and test phases. As in the iterative approach, 2-week cycles were put in place during implementation and involved a planning exercise, coding, as well as a demo. The hybrid approach was additionally characterized by a practice called aligned team structure with system architecture. It implied individual model ownership, meaning that a certain part of the solution was assigned to a single student responsible for its design, implementation, and quality assurance. Now, let's see what were the outcomes of the projects depending on the software method used. Taking a look at the internal project quality, the hybrid laboratory group scored best in terms of number of errors and warnings per line of code. This could be linked to the practice aligned team structure with project architecture, which asks every member to take on responsibility of a part of the project, including the quality of the code. Findings relating to the maintainability ranking, however, were not in line, as hybrid teams scored lowest, while the other two groups demonstrated very similar results. This low score stems from negligence of PHP code quality verification. Only 20% of students from hybrid teams declared regular use of the supporting tool Better Code Hub. With regards to the external quality facet, results for both sequential and iterative approaches are almost identical. The hybrid teams exhibited the highest values of functional adequacy, roughly 5% above the other two methods. Although all groups were expected to produce the same test-related artifacts, the means of execution differed. Iterative teams were to test the functionalities as part of definition of done, while for sequential and hybrid groups, it was a one-off during a dedicated testing phase. It is plausible that the highest scores of the hybrid teams is an outcome of combining incremental delivery and formalized testing phase. The first practice ensured more value was provided early, thus more functionality was tested systematically during the testing phase, and in turn, the final assignments demonstrated higher functional adequacy. When it comes to the second success dimension evaluated, the results of teams' output show a clear discrepancy between the treatments. The median value of functional completeness for the iterative approach is much more lower than that of sequential and hybrid way of working. What probably greatly contributed to that is an intermediary milestone present for the latter two approaches. 2 weeks prior to the final deadline, the testing phase started, and during the last class, students were to execute defined test cases on a nearly complete solution. This naturally shifted the peak of their implementation efforts earlier, so that they could test a semi-finalized project. Data on team cohesion was regrouped into positive and negative impressions, and represented as a function of course progression. All teams started off with around 83% of positive perception of team cohesion, then the metric gradually degrades for the iterative and sequential approaches. On average, hybrid teams exhibited the highest level of teamwork quality, despite a sharp dip at the end of the first iteration. For more analysis on this aspect, please refer to our paper. Finally, a total of 10 course learning objectives were evaluated using a 4-degree rubric system. The results concerning programming skills were not consistent nor differed much between groups. We found it challenging to establish a link between technical skills development and use of a given software process. However, the hybrid way of working brought about a much more positive perception of soft skills acquisition. Hybrid teams scored highest in all of the evaluated aspects of collaboration, consistently securing the highest share of soft skill rated as excellent. For most of the categories, the sequential group came in second and the iterative third. Now, let me recap the experiment. With this work, we aim to investigate if a hybrid way of working brings added value to student computing projects as compared to the processes it combines, iterative and sequential. Indeed, positive impact was observed on the product, project, and people involved. While the methods used imitate industrial practice, our observations cannot be extended to a professional setting without further research. Instead, the patterns observed can serve for other educators who wish to tailor a software development process for academic needs. Based on our experience, we therefore provide certain guidelines. Coupling incremental project delivery with formalized quality assurance, as applied by the hybrid teams. Introduction of the practice aligned team structure with system architecture, as each member's full accountability of a given system module provides clear distribution of work and contributes to a positive working environment. Finally, regular and formalized communication with team status meetings and progress tracking. Such practices could provide particularly useful in the context of remote learning. Thank you for your attention. Now it's time for Q&A.
Okay, hello everyone. Welcome to the Q&A session for this paper. First, I want to congratulate the authors for preparing such a professionally made video, which made it really easier. It was the best video that I've seen actually in all of my sessions. So thank you for that. We have the author, Rafal, here to answer any questions. Please put them in the chat window, and he will respond to you. And after the Q&A session, we invite everyone to join the discussion room to meet the author. So any questions or comments? No? In that case, I will get the ball rolling, perhaps, until we have some questions in the chat window. So, Rafal, in your recommendations, you stated that the conclusions are meant for educators designing like project-based courses, and they happen in an academic setting. But I'm wondering whether the goals should be to prepare them for their jobs rather, and if that is the case, are there any insights that you can maybe transfer from an academic setting to an industrial setting from your study?
So I would say that more research is needed to be able to extend the findings to a professional setting. Working with students has its own specificities and particularities, so definitely not everything will extend even after more research. However, already working with a specific process, especially a hybrid one, is something that I encourage, because this is something that probably the students will also see once they become practitioners. This is something more and more common in companies. But to answer,
some people say that there is no pure process. Every process is a hybrid because you always bring in some outside ideas. So there is no such thing as pure extreme programming, pure Scrum, pure whatever.
Exactly.
Okay, so we have a question from Octavio. 10 weeks format for the project, is it enough time? Would you expand it if you could?
I think that 10 weeks, so there were 5 classes, and every class took place every 2 weeks. So I think this is the bare minimum to be able to introduce a process, because if the project is too short, the class is too short, probably the trade-off is just not worthwhile. And I did a similar exercise with a longer class of 15 weeks. And indeed, it just gives more flexibility of what can be introduced and how much effort can be, can come from the process itself. So I would encourage using it to longer projects as well, but I think 10 is enough.
Okay, all right. And we have Ita. Ita is saying that she very much enjoyed your presentation. I'm sure that is the case for everyone. I'm wondering whether the background of the teams could have made a difference for the results. I do think that use of hybrid is good, as given Corman et al.'s work in Elena, this seems to be what is happening in industry.
So my answer would be definitely. So in the setup of this experiment, allowed to verify the results of the outcomes of the process itself, because all the students had very similar acumen. And I did a similar exercise with master students, and their skills and knowledge had direct impact on all the metrics. So what we observed, that students that were more prone with programming skills produce software of higher quality, both internal and external quality-wise, actually. So it sort of diminished the results of the process itself.
Okay. So maybe we can talk about a little bit the external quality results, because they were surprising to me in a way, and in some other ways they were not surprising. So what I noticed was that when we were describing the 3 different processes that you compared, 2 of them had explicit testing phases with explicit instructions, and then the students are super aware that they have to do some testing. Whereas in the iterative one, I didn't see any, at least in the presentation. So I'm wondering whether that was the case. Maybe this is one of the factors that caused the difference in external quality results.
Right. So in order to avoid bias in this regard, to answer your question first, yes, there is no dedicated phase in the iterative approach, but the students were required to perform tests as part of definition of done, and to verify and to make sure that that happens at the end of the course. So whenever the final assignment was handed in, the students were also expected to provide the requirements traceability metrics, which was sort of the only deliverable around testing, and which was also used by other approaches. So it's just really the way how it was enforced.
Did you actually look at like how many tests they wrote versus the students in the other groups?
Yes, as well, because there were test cases, like sort of definition of test cases, written test cases, and it requires traceability metrics, which made a link between all the requirements, the test case definitions, and the results. So indeed, in theory, the iterative teams also did all of that exercise. It's really up to them, sort of to what extent they pushed the tests.
Right.
But in theory, all the teams were expected to do the same level of testing.
Right. Yes. I mean, like we have run experiments of that sort in the past, and kind of our observation was that even if they're supposed to do testing, if testing was not very, very explicit, yeah, it's always part of definition of done. They just felt free to just skip it. When it's time to do the next iteration, they just move straight to the next iteration, and with the idea that they can complete the test cases after the fact. And in the end, they end up doing actually very little testing, although testing is supposed to be part of the process.
So indeed, this is what happens on the ground. Yes.
Yes. Yeah. Yes. All right. Okay. Are there any questions? I'm not seeing anything on the chat window. Maybe you can comment on the productivity results as well. I am wondering whether when you were measuring productivity, a requirement or piece of requirement was considered delivered, even though it was buggy.
Yes, so there were two metrics. One was really if the functionality was present. So if I saw, like, for example, that there was a reaction to whatever I do in the app, so that meant that it worked. And the other metric checked if there were any issues and anomalies. So that's the external quality. So we had both, a combination of both. And whenever there was a response from the system on an action, and there was sort of any kind of a result, then it was considered that the functionality is there. And would be penalized with the other metric.
All right, so then you were really separating like productivity from quality and not mixing the two together.
Exactly.
All right, okay. Thank you very much. We have another minute and 40 seconds. Are there any comments, questions to Rafal? Otherwise, what I'm going to do is first, I want to thank Rafal again for answering the questions and for the wonderful video. I can't say how much I appreciated it. And it made it a pleasure to actually watch it.
It was a lot of effort, but I think the recording itself was 1.5 hours. The worst part was the slides, actually.
Yes, but it looks like it paid off because it was really enjoyable to watch it, actually. So let's give it up for Rafal. Thank you, and please join him in the discussion room when you are prompted to do so. Thank you, Rafal. Virtual applause goes to you. Okay. And in about 50 seconds, we will be asked to go to the discussion room. So feel free to do that.
All right.
Okay. See you soon.
See you.